Now the eigenvalues of this A psi state is E minus H cross psi, which we have shown in my previous video. If A is applied twice, I will get energy eigenvalue E minus twice H cross omega, and after applying n times, I'll get E minus n H cross omega. But there is a restriction on the application of A. I cannot apply A as many times as I want, because we are then stuck at some eigenstate, some energy state psi 0, which has the lowest value of energy, and that lowest value of energy is E0 equal to half H cross omega. This is called ground state. I cannot go beyond ground state, so I cannot apply A when we reach psi 0. But when we apply A, when we apply A on psi, A psi 0, now the A dagger psi is an eigenstate of the Hamiltonian with eigenvalue E plus H cross omega, which I have already shown. And if I apply A dagger twice, I will get E plus twice H cross omega. And if I apply n times, I will get E plus n H cross omega. Let's start with the ground state energy value half H cross omega. This is how I can generate the excited states by applying a dagger operator on the ground state psi 0. So this is my ground state energy value half H cross omega. I know that if I apply a dagger on psi 0, energy value will increase by an amount H cross omega. So now my energy value is 3 by 2 H cross omega. If I further apply the A dagger, energy value will further increase by H cross omega. So it's now 3 half H cross omega plus H cross omega, which gives me 5 half H cross omega. That means when we apply n times the A dagger operator, the energy eigenvalue for the harmonic oscillator will be En equal to n plus half H cross omega. This half factor is actually a contribution of uncertainty principle. Now let's find out the length of these eigenstates, the length of the states. If psi n is nth arbitrary state, A psi is an eigenstate, A dagger psi n is also an eigenstate. What will be the length of these states? Let's see the time independent Schrodinger equation or the energy eigenvalue equation of the Hamiltonian H. If psi n is eigenstate of H, then it will give me energy eigenvalue En corresponding to the psi n eigenstate. And as psi n's are normalized, so psi n is equal to 1. We know that A psi n is an eigenstate with the eigenvalue En minus H cross omega, because that is the action of A operator. Now we write this En minus H cross omega as En minus 1, for example. So here I can write that A operating on psi n gives me this constant C minus, and now my energy eigenstate is psi n minus 1, because for n minus 1 the energy eigenvalue is En minus 1. These states are also normalized like psi n's, and I also write this as that A dagger operating on psi n gives me C plus, scalar quantity, a number, and now the energy eigenstate is psi n plus 1, because now the energy value is increased by an amount h cross omega, which we will call as En plus 1, just like here I call this as En minus 1. So if it is En plus h cross omega, so we will call this En plus 1, and the corresponding eigenstate is psi n plus 1. Now if I start with a psi n, this is constant and this psi n minus 1 is there. Making dual conjugate of this equation, I will get this. This psi n becomes bra psi n, this will become a dagger. This is a complex number, so it will be C minus star, and this ket psi n minus 1 will be a bra psi n minus 1. Now making scalar product of these two, left hand side I will get this, right hand side I will get this, because C minus star C minus is nothing but C minus mod square. The wave functions are normalized, so this portion is equal to 1, so I am left with C minus mod square. Right hand side I have this, left hand side left hand side I have this, right hand side I have C minus mod square. Starting with the left hand side and substituting a dagger, with the a dagger A with this relation, what we have derived earlier, we get this. I am splitting the two terms, I am doing some algebra. H cross omega can be taken outside because H cross omega is just a number. H operating on psi n will give me En, that is the eigenvalue equation of the H Hamiltonian itself. Psi n's are normalized, so this becomes 1. I get only half from this second term. From this first term, I have En. Again psi n is normalized, and that is equal to 1. So here I have En by h cross omega minus half. En is nothing but n plus half h cross omega. And if I do some algebra of it, it is quite simple. I will get only n here for left hand side. Right hand side I already have C minus mod square. So C minus mod square is equal to n, and C minus is equal to root over twice n. Previously I have written that A psi n equal to C minus psi n minus 1, and in place of C minus, now I can easily write root over of n, and this is my equation number n. So this C minus is root over of n, and the equation n tells me that when A operates on A or A minus, that is the lowering operator, operates on energy state or any state psi n, I will get root over of n, and the state will be psi n minus 1. I need this relation in future. So many times we need to use this relation. Let's find what is the length of a dagger psi n. I will do the same algebra as I have just done here. So it's a dagger psi n. I write this as C plus psi n plus 1, because when I apply a dagger on psi n, the energy eigenvalue will be h cross omega, energy eigenvalue will be En plus h cross omega, and the corresponding state is psi n plus 1. I am making a dual conjugate of this relation, and I got this. C plus is a complex number, so it will become C plus star. If I make scalar product of this and this, the left hand side will become this, and the right hand side I will get this. Psi n minus 1 states are they were normalized states. Similarly, this psi n plus 1 states are also normalized, which means this length is equal to 1. So I'll get C plus mod square equal to psi n a dagger psi n. Again I substitute for this a dagger the Hamiltonian itself, because then I will be able to use the eigenvalue equation of the Hamiltonian. So left hand side, in place of a dagger, I will use this equation. I will split this two terms, and here I will apply the eigenvalue equation of the Hamiltonian. It's H psi n equal to E psi n. E will be taken outside. Psi n must be equal to 1 because psi n's are normalized. So I get En by h cross omega from the first term. From the second term, this is 1, and I will get half from the second term. And En equal to n plus half h cross omega. So the first term is n plus half h cross omega by h cross omega. I get n plus half, which is equal to n plus 1 in the right hand side. Left hand side we had this. Right hand side we have just obtained n plus 1. And we can write this C plus mod square equal to n plus 1, because we had this relation, this a dagger psi n equal to C plus psi n plus 1. So this C plus is now root over n plus 1, and I get equation O, which tells me when a dagger is applied on psi n, I will get root over of n plus 1, and the state becomes psi n plus 1. Now what is the utility of this equation n and this equation O is that if I know the psi n, then I can easily obtain this higher excited states. We can also obtain the lower energy states. Let me give you a disclaimer here that this a dagger and a, that is the ladder operators, raising and lowering operator, they do not refer to position or momentum. They are not Hermitian operators.